Welcome back. This is logic coding. Today I've been making tons of video because tomorrow I have my on-site interview for one of the self-driving companies. I haven't been practicing on-site for a while. I guess this is the practice for the intensity. I do want to go through every category, just I have all the tools at least in my head. So now coming from a sliding window / two-pointer question called minimum window substring. So we have two strings. We have a string S and we have a string T. And we want to return the minimum window substring of S. And what's the constraint about this sliding window is that every character in T, including duplicates, will be included in the window. If there is no such substring, we want to return empty string. So our output should be either a substring of S or just an empty string. And the test cases will be generated such that the answer is always unique. So we will not have two substrings with the same length that satisfy the constraint. The substring is a contiguous sequence of characters with the string. Okay, cool. I think we know about the input and we know about the outputs. Now let's consider what algorithm should we use. So whenever there's like a window or there's a maximum or minimum window, we know that we can use sliding window and we need a pointer to expand the window, and we need a left pointer to shrink the window, right? But when we do a sliding window problem, we normally need to maintain some data, extra data to help with the constraint, right? Like what do we need with this problem? So if we go back to the question, the constraint is that we require every character in our string T is included in our string S. So a natural way is to use a hash map, or if it's character, we can just use a vector of int. And we can keep a count to say, okay, now if count equal to 0, which means I have balanced. At first, I initialize my hash map so that every character in T will be counted, that the frequency will be counted in this map. And then whenever I have a similar character in S, I will just minus, and when my counter equal to 0, I know that this is a valid sliding window and I need to shrink the window to find the optimal, the smallest one. Okay, cool. Then, of course, for a sliding window, we only like sliding the window. The time complexity will be OM, and the space complexity will just be those two pointers. Will just be those two pointers. While the concept is not exactly difficult, there are some of the tricks for this question. We can dive it out. So first, let's create a vector of int as our map. If it's characters, we can just do this, and then for every character in T, we can just map this into our, we can just plus this one. And then now let's do our sliding window. We start from the right hand side. Left pointer also start from 0, and since we want to return a string, so we need to have a starting index. Let's do 0 as well, and length let's equals to max. So if we find a valid window with finite length, we will be able to update this length and update this start index so that we can extract the substring from this S. So we know that if we want to return at the end, if the length does not get updated, I will return empty string. Otherwise, I will return a substring with start index and the length. Cool. Now let's slide our window. So expand the right side. We will do while while my right pointer is still less than the end, what we'll do is we should always count my right as negative negative. But if my map right is positive, which means it's one of the character in T, I need to reduce my count as well. So let's do a count. Actually, I need to initialize my count as the length of T dot length, right? Because I need to have those many characters to balance off at the last, and then I move my right pointer. Then when my window is valid from the valid from right side, what I need to do is I need to shrink my window, shrink the window by moving left pointers. While my count continue equal to 0, what I can do is I first update the window, right? Like if I know it's always valid. If right now my right minus left is smaller than my length, one thing is, do I need to consider the size? Should I do like -1 or 1? So my left is considered and my right is plus plus. Did I include, for example, if I have A, and then I literally just have a character, and then after my right equals to 0, after this my right will be equal to 1, right? 1 minus 0, yes. Okay. And I would update my starting index equals to left, and I will up my length equals to right minus left. Cool. After updating, let's move the left pointer. I know I need to move left pointer, but as long as I'm moving my left pointer, I need to maintain my map. So what I will do is I will do left negative negative. If I find my map left is actually greater than 0, if I find my map left is greater than 0, like when after, like how should I say it's greater than 0 or equal to 0, equal or greater than 0, I should do count plus plus, right? Map as left minus minus or plus plus. Because on the right hand side I'm minus this, on the left hand side I should increase it back. If if I have some character, if my left happen to be 1, if my left right now equals to 0, and yes, I should do plus plus. Let's run the code. Submit it. Woo! Wow. Okay, I didn't expect it to pass. Okay, great. I think I'm still not really sure about this part. Like when move left pointer, how should we maintain this map? So I know if the character is not in the if its character, the frequency is smaller than 0, then we know that It's like not in T, but if it's greater than that, then we should just do count plus plus. But if it's negative, then we should just be balancing the previous minus, like minus minus out. Yeah. Definitely need to draw out a little bit more, but for the sake of the time, I think this would be the end of this video. And yeah. So one thing I do want to say is that for sliding window, in order to, normally we have some extra data structures to maintain the status of the window. For this one, it's a map. To move the right pointer, we can either write a while loop with right plus plus somewhere in the loop, or we can write a for loop, which make right pointer move one by one. And then whenever we move the right side, we need to update the sliding window status. So we use both count and a map for this case. And whenever the constraint is satisfied, we need to either shrink the window. When we shrink the window, we update the necessary answer if possible. And then when we move the left pointer, just like the right pointer, we need to again maintain our auxiliary data, like the map and count. And for each of them, there might be some constraint associated with that. So it's problem by problem, but that's the gist of the sliding window problem. Thank you guys for watching, and I will see you next time.